All right. We're in 13.3 where we're using probabilities using combinations. Now, beforehand we talked about permutations. Today, we're going to use combinations. Now, permutations was selecting arrangements where order was important. Today, in combinations, you're selecting objects in which order is not important. So, like we had um, the word cat in previous examples. With a permutation, we had 6 different ways that we could arrange it with a permutation. Now, if we were talking about combination, the answer would be 1, because it didn't matter where we put the C, the A, or the T, just as long as you had them in some type of order. So, and as long as you had them in some type of order, you didn't have to rewrite them. So it was just the one time. I'll explain this a little bit further. Say for this example, we have to count the combinations of 2 letters from the list of A, B, C, D, and E. Now we're not going to repeat anything, so all I want to do is I want to find what the first off, I think what I'm going to do is I'm going to make a list of all the types of permutations that I could find. So let's go right off the bat. Let's say it's A, B. That's 2 letters. So then it could also be A, C, A, D, and also A, E. Now we can go B, A, B, C, B, D, and B, E. We can go C, A, C, B, C, D, and C, E. We can go D, A, we can go D, B, we can go D, C, and we can go D, E. And then we can go E, A, E, B, E, C, and E, D. So that gives me 1, 2, 3, 4, 1, 2, 3, 4, 5. So this, for permutation, we get 20 arrangements. Okay? Now with combinations, we don't have to take into account for order. So since we see we have AB right here, we don't have to, BA is writing it the same as AB. With order doesn't matter. That means we can X this out. We got AC right here, but we don't need CA. We got AD, that means we don't need DA. We got AE, that means we don't need EA. We got BC, that means we don't need CB. We got DB, which means we don't need, or BD, we don't need DB. We have BE, that means we don't need the arrangement EB. We have CD, we don't need DC. We have CE, that means we don't need EC. And we got DE, that means we don't need ED. So we count the circle ones: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for combinations, we got 10. And yes, there's also a formula for this. So the combinations formula is, if we have a number of combinations of n objects taken at r at a time, or again, where r is less than or equal to n, it is given by n factorial divided by r factorial times by n minus r factorial. So for this particular sequence, it would be, this would be C, and we'd have 1, 2, 3, 4, 5. We'd have 5, and we'd have arrangements of 2. So then if we use our formula, we got 5 factorial divided by 2 factorial times n minus r, which makes that 3, so that's 3 factorial. So then we got equals, the top would be 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And then we got 3 factorial, which is 3 times 2 times 1. And then the 3's cancel, the 2's cancel, and the 1's cancel. So we're left with 20 divided by 2. And 20 divided by 2 is 10. And that's where we get this answer. So let's do some examples. So if, let's say you choose 2 courses out of a possible list of 6. You want to know how many combinations of electives are possible. So by using this formula up here, I have a combination where I got a list of 6. So that means my n's going to be 6, my r is going to be 2. So this is going to equal 6 factorial over 2 factorial, and it's going to be 4 factorial, which then this equals 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times by 4 times 3 times 2 times 1, and cancel, 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 which then leaves me with 30 on the top divided by 2, which equals 15 combinations. So again, the difference between permutation versus combination. Permutation order matters. For combination order does not matter. So if I'm going to evaluate, say, the combination of 13 objects under 10 at a time. So if I'm going to use this, the formula we had up there, that means it's going to be 13 factorial divided by 10 factorial. And then in here is going to be 13 minus 10, which gives me 3 factorial. Which this equals, well, what I'm going to do is I'm going to go 10 factorial times by 11 times 12 times 13. And I got 10 factorial, and then 1 times 2 times 3. So then the 10 factorials cancel, so then I got 11 times 12 times 13, which gives me 1760 on the top, divided by 6. And that total gives me 286. Okay. This last example deals with probability. And the question says that your teacher randomly chooses 2 of the 18 students to give an impromptu debate on freedom of the press in high school newspapers. What is the probability that the teacher chooses you and your best friend? So just like finding probability with permutation, finding probability with combination has steps in it. So step 1 is, first we must find the combinations of n objects taken r at a time. So for this particular one, we're going to go C. We have our n is going to be 18, and our r is going to be 2. And writing this out, we got 18 factorial divided by 2 factorial. And then this would be what, 16 factorial. So then this equals, I'm going to put 16 factorial times 17 times 18 divided by 16 factorial, and then my 2 factorial, which would be 2 times 1. So 16 factorials cancel. 17 times 18 equals 306. Denominator is 2. So that means there's going to be 153 possible outcomes. Step 2 is I want to know how many favorable outcomes. So I want to know what the probability is that the teacher chooses you and your best friend. So it doesn't matter which order it's in. So there's only one favorable outcome where it's you partnered up with your best friend. That's the only outcome that works. And so step 3 is you take the number of successful outcomes, which in this case is 1, divided by the total number of outcomes, which is 153. So your answer for the probability of you and your best friend being chosen for this debate would be 1 out of 153. And that's finding probability using combinations. Hope this helps. Until next time.